Okay, يعطيكم العافية شباب. I will have to start the class. I cannot wait more than 3 minutes. هلا we will start today inshallah in section 17.4, which is the function of complex number. In this section we will talking about the definition of function of complex number and how we can find the imaginary and real part of the function, understanding the concept of limit, computing the limit, and we will discuss the concept of the differentiability and the harmonic function and the analytic harmonic function. And let us start from the beginning, the concept of the function of complex variable. What do you mean by a function of a complex variables? A function of complex variables here from calculus, you know that when we have the function f defined from a to b, we say that the function f of x is equal, for example, x squared. This is single variable function with the domain a and the range contained in b. And my variable here x is real number, and that's called real valued function. Real valued function اللي هو where we talked we studied this one in calculus. الآن for the complex number the complex number here we will have my domain, the set of A. It will be an element of complex numbers. So when we have the function f من A إلى B, where f is a complex valued function. F is a complex valued function. What do you mean by complex valued function? It means the domain of my function is a complex real numbers, will be is the imaginary is the image of the function f also is a complex number. That means the complex number z is equal x plus iy will be imaged under imaged under the function f to another w of complex number, which is we'll call it later on u plus iv. So a complex valued function is a function where its domain is a complex numbers and also a range is a complex numbers. الآن usually we will say that w, the imaginary part of the complex number, we will call it w. هلا the variable of this complex number هي عبارة عن z. When we have z is equal x plus I في y, w also it will be a complex number, which is the image of the complex number z. W also it will be written in the form u plus iv. So we will have u plus iv to be f of x plus iy. U is a part of the image which is called the imaginary part, the real parts. Will v also it is the imaginary part. But here u is a function of two variables. Also v is another function of two variables, x and y, but those variables x, y are real variables, real numbers, I mean real numbers. U, it will be a function of real part where it is denoted by u, which is exactly means u of x, y, where x, y is a real variable number. Well, v is the imaginary part of my image. Also v is a function of the two real variables x and y. الآن we can express the function f of z to be w to be equal W. W, it will be as U of xy plus I times V of xy. alright. طيب الآن خلينا نشوف الآن as an image على الشكل عندي هون. هلا we cannot draw the graph of a complex function. We cannot draw the graph of a complex function. Can be interpreted as a mapping or transformation from Z plane to W plane. Why? Because the Z plane, which contains the domain of my function, it is located in R square, which is the complex number here, the complex number C, which is the two variables, because each complex number will be denoted by as a pairs x y, which means x plus iy. Also, the image of this complex number, it will be in the W plane. With W plane, it has real part and imaginary part also. So الآن total dimensions will be 4th dimensions, and we cannot imagine 4th dimension. ما نقدرش نتخيل البعد الرابع. And even the computer, we cannot sketch in 4 dimension, but they can make a projection and give you a part of your graph. طيب, let us to see some example. بيقول لي let the function f of z is equal z square minus 4z. هلا z here is a complex number. A domain this function is the set of all complex number which is allowed to be substituted here. A domain for this function f is the set of all complex number because this is a polynomial. هذا عندي polynomial هون. الآن if I would like to find f of 2 plus I, it is equal to 2 plus I square minus 4 times 2 plus I. Of course, we have to calculate this one. That becomes 4 plus 4I, I square here minus 1, minus 8, minus 4I. So we can simplify this one. 4 plus or 4 minus 9 becomes and then a minus 5. 4I minus 4I بيعطيني ايش؟ 0. وهذا بده يساوي minus 5, which is equal minus 5 plus 0I. طيب نشوف next one. أو لو ناخذ another example for this one. If I said f of I, it means I square minus 2I, واللي هي عبارة عن minus 1 minus 2I, minus 4I for example. 4I. طيب الآن f of z is equal 1 by z. What's the domain of this function? Here I have to avoid the zeros of the denominator. So a domain of this function f, it will be the set of all complex number except the zero complex number. طيب خلينا ناخذ some examples على هذا. إذا بدنا نوجد عندنا f of I means 1 by I. We calculate this one last time, it becomes minus 1. F of 1 also 1 by 1, which is 1. F of 1 plus I, but you say 1 by 1 plus I, واللي هي 1 by 1 plus I times 1 minus I على 1 minus I, واللي هي 1 minus I على 1 minus I square واللي هي minus 1. So that becomes here بيصبح معنا 1 minus I على 2, which is half minus half I. نشوف النكست one. بيقول لي f of z is equal z by z square plus 1. How we can calculate the domain? Domain of this function f, it will be a complex number except zeros of z square plus 1, which means that is equal the set of all complex number except the complex number z such that z square plus 1 is equal 0, واللي هي عبارة عن الcomplex number except هلا z square plus 1, that means z square is equal minus 1. Z such that z square is equal minus 1 وهي this is equal the complex number except the z square is equal minus 1. It is either I or minus I. I or minus I, because minus I square also is equal minus 1, and I square that's minus 1. So the set of domain I, this is the complex number I, or this one minus I. So I have to take all the points here except those 2 points, or those 2 complex numbers I and minus I. طيب نشوف z f of z is equal z plus real z. What's the meaning real z here? If we take z to be x plus iy, then f of z, then real z, it will be x. So f of z here, it will be f of x plus iy, which is equal x plus iy, which is the complex number z, plus real z, which is x, وهذا بده يساوي معنا 2x plus iy. هلا there is no any problem here for this one, so the domain of this complex number is the set of all complex numbers.
Doctor, why would we add x?
Because x plus iy plus x plus real z. Real z, it is x, because this is the z complex number. يعني هذا الكومبلكس نمبر z اللي هو x plus iy. شو الريال تبعه؟ x.
x. Okay.
طيب نشوف النكست example. بيقول لي find the real and imaginary part of the function f of z is equal x z square. f of z is equal z square. ايش هو الريال and imaginary part? First of all, we have to assume z to be x plus iy. هلا f of z بده يساوي عبارة عن x plus iy square، ألا هو x square plus 2i xy plus اللي هي iy square, which is equal x square 2i ل xy I square اللي هي minus 1 times y square. Now rewrite the real parts together واللي هي x square minus y square plus I times 2xy. And then this one here I have to say that real part uxy عبارة عن ال x square minus y square and imaginary part هو عبارة عن 2xy. I should clear this example. Any question for this one? طيب نشوف الآن next example. قال لي find the real and imaginary part of the following function. First of all, here the domain of this function is equal the set of all complex number except the zero complex number. Assume z to be x plus iy. هلا f of z بتساوي 1 by x plus iy multiply by its conjugate becomes 1 plus x plus iy times x minus iy على x minus iy. هلا that becomes x minus iy divided by x square minus plus y square plus y square. لأنه x في x square x iy minus x iy بتروح 0. هلا I في minus I becomes 1 y في y becomes y square. طيب الآن this is becomes as x divided by x square plus y square minus or plus I في minus y divided by x square plus y square. إذا عندنا هون الريال part وعبارة عن x divided by x square plus y square والimaginary part اللي هو minus y على x square plus y square. And that's all. Any question here for this example? طيب this is just a remark that we can interpret the complex number w is equal f of z complex function as two-dimensional fluid flow by considering the complex number f of z as a vector based on the point z. I mean, if we consider f of z, which is w, as a vector, the vector f of z specifies the speed and direction of the flows at a given point z. This is just a matter of example how we can interpret f of z. طيب الآن بنروح على مفهوم limit, second part, which is the most important thing for me, honestly, here, the concept of the limit in a complex number. طيب الآن maybe this concept it's not easy for you because you study the limit of function and sequences in calculus in something different without using something called epsilon and delta. طيب شوفوا كيف. If we suppose that we have a complex number defined in a neighborhood of z naught except possibly at the point z naught. I mean, I have a complex number, I have a complex function f of z. Maybe it is defined somewhere around in a neighborhood around z naught. This neighborhood, it has a radius delta. But it's not necessary the function itself to be satisfied at z naught. الآن, we said that limit the function f of z is equal L when z approaches z naught if for every epsilon أكبر من delta there is أكبر من 0 there is delta greater than 0, such that when f of x, f of z minus L absolute value less than epsilon, whenever z minus z naught absolute less than delta. What does this mean here in math? It means that a limit f of z is equal to the complex number where z approach to z naught. We can claim this one if and only if I take any epsilon neighborhood. It means any neighborhood around L. This neighborhood, it has epsilon as a radius. For this epsilon neighborhood around L, I should find a delta neighborhood. Here delta, it will be depend on epsilon. I should find a delta neighborhood around z naught, such that any number z in this delta neighborhood, its image, it should be f of z in this epsilon neighborhood. Therefore, if I, when I said for every epsilon greater than 0 there is delta, that means delta will depend on epsilon, which means that when you change epsilon, it should be delta changed. When you change the epsilon neighborhood around L, it should be the delta neighborhood around Z naught is also changed. Therefore, for each epsilon, you will find it is corresponding delta, which means that delta will depend on the value of epsilon. Each time you will be changed. I mean, if you make this delta is bigger, epsilon is bigger, then you should have another delta around Z naught. That's every complex number within the delta neighborhood around Z, it should be its image here in this epsilon neighborhood around L. Of course, this definition is not easy for you to deal with it, but I'm teaching this one for the math students for in advanced courses, and they have to find the limit by using epsilon and delta. But in this course, it's not required to find by using epsilon and delta. طيب الآن another important remark here. Another important remark. في عندنا ملاحظة ثانية مهمة هنا على الإبسلون and neighborhood. That when you find the limit for any complex function to approach the Z naught, you can approach Z naught from infinitely many different paths. So from where you approach the Z naught, you should have the same limits. I mean, for the limit of complex number here, if you remember the limit of calculus 3 for function of two variables, you should approach the point from infinitely many paths, and all of these paths, their limit are the same value. الآن Z allowed to approach the number Z naught from any direction in the complex plane, that is along any curve or path through the Z naught. In order that when we find the limit of f of Z, to make sure or to guarantee its exist and equal the number L, we require that to approach f of z, it should be approach the same complex number L from wherever the path to z naught is taken. I mean, along every possible curve through z naught. I mean, whatever the path you take it to approach z naught, it should be f of z approach to the number L. In this case, I can guarantee. Therefore, in case I have two different paths with two different limits, then the limit it should be does not exist. If I find two different paths, they have two different limits, then the limit of f of z does not exist. طيب الآن خلينا نروح على قوانين الليميتس. Let us to go to the limit properties. Most of them or all of them are the same properties of the limit from real valid function from calculus 1. If f of z it is limit is equal L1 when z approach z naught, and gz is equal L2 when z approach to the same point z naught, then limit of a constant times f of z is equals the constant c times the limit, which is here is equal c times L. Limit f of z plus minus g of z when z approach z naught is equal L1 minus plus L2. I mean, the limit will be distributed in addition and subtraction at the same time. Limit f of z times g of z when z approach z naught also is equal L1 times L2. L1 times L2, which is here means is equal limit f of z times limit g of z where z approach z naught. Limit f of z divided by g of z where z approach z naught. Also, you can distribute a limit on numerator or denominator, provided that the limit of denominator is not equal 0. بشرط ما يكونش عندنا limit للمقام تساوي 0. الآن for any polynomial for any function of complex number defined as a polynomial, in limit it should be just only a matter of substitution the complex number z naught. It's the same as the limit in calculus. For example, when we have z is equal z to the power 4 minus 3z square plus 2iz plus 5 minus 2i, this is a polynomial. This is polynomial of complex numbers. Or if we take that, we say f of z, for example, z to the power 4 في z square plus 1 I z square. Also, this is polynomial of complex numbers. Now, what's the meaning rational function in complex? Rational function in complex, it is the same definition of rational function in calculus. It is a polynomial divided by polynomial, so it is called a rational function. It is called a rational function. يعني مثلا when we said that f of z is equal z square plus 1 divided by z cube minus 1. This is a rational function of complex numbers. If we say that f of z is equal 1 by z square plus 3z, or we said that f of z is equal 1 by z plus z, because this one is equal 1 plus z square by z. All of those are rational functions, rational complex functions. الآن but if we say that f of z is equal to 1 by modulus z plus 1, this is not a rational function. Why not rational? Because I have modulus z here, not z to the power, because the denominator is not a polynomial. Or if we have z is equal z conjugate by z square, also this is not rational because I have z conjugate, not z power. Or if we have z is equal modulus z by z square plus 1, all of these are not rational. Functions. الآن, in case we have a rational functions polynomial by polynomial, the limit for this function f of z when z approaches z naught is equal p of z naught divided by q of z naught. I mean, just a matter of substituting z naught in your rational function, provided the q of z naught is not equal 0. Provided q of z naught is not equal 0. طيب, خلينا نشوف الآن. Let us to see some examples about the limits. Compute limit of z squared plus I where z approach to 1 plus I. هلا you notice that z squared plus I, it is polynomial. Therefore, limit when z approach to 1 plus I for z squared plus I, it's just a matter replacing z by or substituting z by 1 plus I becomes 1 plus I squared plus I ويساوي 1 plus 2I plus I square اللي هي minus 1 and that is a plus I. هلا 1 minus 1 it will be 0. 2I plus I بيعطينا كم؟ 3I. So the limit is equal 3I. Is it clear this example? Any question for this example?
Clear.
طيب نشوف النكست one. بيقول لي compute the limit of 3 plus I times z to the power 4 minus z squared plus 2z divided by z plus 1 when z approach I. This is rational. This is rational function. The limit when z approach I, so it is rational. I is not the zeros of denominator, not the z of not the zeros of denominator. So a limit is just a matter of substituting 3 plus I في z to the power 4 minus z square plus 2z plus 1 بده يساوي a limit of 3 plus I. هلا substitute I to the power 4 minus I square plus 2I divided by I plus 1 where without limit because we just already substituted the values. Now we need to simplify only. هلا I to the power 4 بيعطينا كم؟ I في I square which is minus 1 times I minus I times I, it will be 1. So that becomes 3 plus I times 1 minus I square which is minus 1 becomes a plus 1 plus 2I على I plus 1 وهذا بيساوي 3 plus 1 بيعطينا اللي هي 4 4 plus 3I divide I plus 1. But here we need to simplify. How? Multiply by الconjugate بصير 4 plus 3I على I plus 1 times 1 minus I على 1 minus I والمultiplication هون بده يصير معنا في الدينومينيتور بده يصير معنا 2 هلا 4 في 1 4 وماينس 4 I و3 I minus 4 3 بيعطيني I so minus I sorry والآن عندنا 4 وI في I وفي minus I بيعطيني 1 ضل 3 و4 plus 7 minus I plus 7 divided by 2 وهذا finally بده يساوي 7 divided by 2 minus half I. So this is the limit here. Yes. Yeah, Muhammad Hassan, تفضل.
Doctor, is it the conjugate is 1 minus I minus 1? It's okay to write it 1 minus I.
Yeah, minus I plus 1 or 1 minus I are the same complex.
Oh, okay. Thank you.
All right. طيب. Limit for Z plus I على Z square plus 1 when Z approach to minus I. Who can solve this one? مين يحل لي هايدي؟ يلا نشوف. مين يحل هذه؟ مين عنده any idea؟ مين يقول لي ممكن كيف يحلها هذه؟ ما حدا؟
Maybe you multiply by conjugate first.
Conjugate.
Yes, maybe. It's not polynomial.
Sorry?
It is not polynomial, right? Because it's power 1 and power 2 in the denominator.
It is polynomial by polynomial. It is rational function. Okay. This is a tricky question. Why it's a tricky function question? شوفوا هون. First of all, this one here, this one is rational. Now, if you substitute a minus I, it becomes minus I plus I, بيعطيني 0. Minus I square, it is minus 1. Minus 1. Plus 1, also 0. But still, I can find the limit. How we can find the limit?
Using left tools.
No.
You cannot use it here.
L'Hopital rule for real valued function.
Maybe you have to substitute z with x plus y.
Have a look here. I have to factorize z square. To factorize it, it's equal z square. هلا ال1 minus I square, it's equal 1. I mean, minus the I square, it's equal 1, صح? So replace this one by minus I square. So this one, when you factor, it becomes z minus I times z plus I. All right. إذا الآن limit for z plus I على z square plus 1 where z approach to minus I, it becomes a limit of z plus I على z minus I في z plus I where z approach to minus I. Now you can simplify. It becomes here the limit 1 by z minus I where z approach to minus I واللي هي 1 على minus I واللي هي 1 على minus 2 I. Which is equal minus half times 1 by I. ال 1 by I we solve it last time by الconjugate بيعطينا كم؟ ال 1 by I هي عبارة عن minus I. هذا شو بده يساوي؟ I divide by 2. Is it clear here? واضح هنا. Any question about this example? In case you get 0 by 0, you have to factorize, simplify, then find the limit for the rest. طيب الآن خلينا نروح على definition of the continuity at a point. A complex number f is continuous at the point z naught if limit of f of z when z approach to z naught is equal f of z naught. So we define the continuity at a point by using the limit. الآن we have the same this theorem by or definition in calculus 1. Now, if we have two functions, f and g, continuous at the point z naught, then multiplying the complex number by any constant, it becomes also continuous at z naught. Or the addition and subtraction of those two complex numbers also will be continuous at the same z point. Also, the multiplication f by g will be continuous at z naught. And the division f by g also is continuous at z naught, provided g of z naught is not equal 0. The same properties of continuity of real functions in calculus. And that's definition here for the continuity at a specific point only, z point. Now, what's the meaning continuous at the domain R? We said f is continuous at the domain R if it is continuous at each point in that domain. I mean, a limit for f of z when z approach z naught is equal f of z naught for all z naught belongs to R لأي نقطة في الدومين عندي. طيب البولينوميال pz all is continuous everywhere all the time. The polynomial is continuous everywhere in the entire on the entire z plane. A rational function will be continuous except at the zeros of a qx in the denominator. A rational function will be continuous except at the zeros of the denominator. خلينا نشوف الآن. Determine the set of complex number in which the function f of z is continuous. هذا الفانكشن اللي عندي هو polynomial. هو ايش؟ polynomial. صح؟ f of z is polynomial. So it is continuous on the entire complex number. So it is continuous on the whole complex number. طيب الآن بيقول لي determine whether the set of complex number on which the function is continuous. Here I have to determine where it is continuous. 1 by z square plus 4. الفانكشن هنا f of z is continuous on the entire complex number except the zeros of the denominator. طيب الآن let us to see how we can calculate z square plus 4 is equal 0. That means z square is equal minus 4. Z is equal positive negative square root of minus 4. يعني z is equal positive negative square root of minus 1 the square root of 4. So which is equal positive negative I times 2. So it will be continuous on the whole complex number except what? 2i minus 2i. those points here where it is not continuous there, because they are not located, by the way, in its domain. Is clear this example؟ واضح المثال هذا؟
Doctor, can you repeat, please?
الآن he said determine where the complex number f of z is continuous. We said here it is continuous at the whole point except the zeros of the denominator. So this function is a rational function and continuous on the set of all complex number except the zeros of denominator. The zeros of denominator we calculated here. Z squared plus 4 is equal 0. Take 4 to the other side. Z squared is equal minus 4. Z it will be positive negative square root of minus 4. So Z is equal positive negative square root of minus 1 times the square root of 4. Positive negative square root of minus 1, it is I. Square root of 4, it is 2. The square root of 8 times b is equal to square root of 8 times the square root of b. Clear here, this example?
Clear.
طيب نشوف النكست اكزامبل. بيقول لي next concepts اللي هو the derivatives. Now we are ready to discuss the derivative because we discussed the concept of the limit and the continuity. Limit and continuity. بيقول لي suppose z is equal x plus iy and z naught is equal x naught plus iy naught. Then the changes in z naught is the difference delta z, which is equal z minus z naught. This is the changes in z naught, which is denoted by delta z. Now, when we said z minus z naught means real minus real, imaginary minus imaginary. So it's x minus x naught plus I times y minus y naught, which is basically equal delta x and delta y. لأنه delta z is equal z minus z naught. الآن, if the complex function defined at z and z naught, then the corresponding changes on this complex number f of z, it will be denoted by delta w, which is equal f of z naught plus delta z minus f of z naught. This is dw is equal f of z naught plus delta z minus f of z naught. Type. Why are we using this one? If you remember the concept of the limit by using the definition from calculus 1, f prime at x is equal limit f of x plus delta h minus f of x divided by h, where h goes to 0. Here we are using the same concept, the same definition. So the definition of the derivative for the complex number at the point z naught, it will be denoted by f prime of z naught, which is equal limit of f of z plus delta z minus f of z naught divided by delta z, where delta z approach to 0. هلا delta z is equal delta x plus I في delta y. We show this one here at the beginning. Delta Z is equal delta X plus delta I times delta Y. طيب إذا in general, let us to write down in general f prime at the complex number Z is equal a limit of f of Z plus delta Z minus f of Z divided by delta Z, where delta Z approach to 0. الآن, if the above limit, I mean if this limit exists, then we say that the function f is differentiable at Z naught. But if the limit does not exist, that means the function f is not differentiable at Z naught. طيب. Maybe we could say that if we have w is equal f of z, maybe we can use the symbols w prime or dw by dz to denote the derivatives. الآن, if f is differentiable at a z naught in a domain D, then it will be continuous at z naught. But if f is continuous at z naught, then it is not necessary to be differentiable at z naught. I mean, this theorem is one direction theorem. In case it is differentiable, then it is continuous. But the reverse need not be true. الآن خلينا نشوف some rules of the differentiation and to see what's the difference with calculus 1. طيب الآن, if we have the two functions f of z and g of z are differentiable at the point z. First of all, d by dz for any constant is equal 0, which is the same rule of calculus with real number. d by dz for a constant time f of z is equal c times the derivative of f. You can take a constant outside. d by z for f of z plus gz is equal f prime plus g prime. The same procedure with negative also. d by dz for f of z times gz is equal f prime times g plus f times g prime. The same rule of calculus 1. d by dz for f divided by g is equal f prime times g minus f times g prime divided by g prime square, also the same calculus, provided g of x is not equal 0. d by dz for f of g, which is the chain rule, is equal f prime at g of z times g prime of z. هلا d by dz for z to the power n is equal n times z to the power n minus 1. d by dz for z to the power n will be equal n z to the power n minus 1, where n is any integer, I mean. الآن, you will see that it's the same procedure of or the rules of calculus 1 for the real function. Okay. طيب خلينا نشوف الآن some examples. Maybe we will not finish this section today. Anyway, الآن if f of z is equal to 3z to the power 4 minus 5z to the power 3 plus 2z. العزة الله ولا إله إلا الله. العزة الله ولا إله إلا الله. Now part A. What is f prime of z here? It is a polynomial. Its derivative, it's something straightforward. عبارة عن 12z to the power 3 minus 15z square plus 2. هلا f prime of z is equal المقام في مشتقة البسط 4z plus 1 times 2z minus البسط في مشتقة المقام اللي هي ايش 4 divide by 4z plus 1 square واللي هو that becomes 8 z square plus 2z minus 4z square divided by 4z plus 1 square. هذا بده يساوي 8z minus بصير معنا 4z square minus 2z or plus 2z على 4z plus 1 square. أشهد أن لا إله إلا الله وأشهد أن محمدا رسول الله. لا حول ولا قوة إلا بالله. Part C. Part C, how we can derive part C. يلا مين يحل معي؟ f prime of z بده يساوي 5 times iz square plus 3z to the power 4 times the derivative of what's inside the brackets. يلا نشوف مين يحل لي هون. 2i z plus 3. لا حول ولا قوة. الله أكبر الله أكبر. طيب خلينا نشوف الآن how we can use the definition of the derivative to derive. بيقول لي use the definition of derivative to find the derivative of f of z is equal to z square minus 5z. Okay? First of all, I have to find delta w, which is equal f of z plus delta z minus f of z. الآن f of z plus delta z, it means that go to your function and replace instead of each z, z plus delta z. So that becomes z plus delta z square minus 5 times z plus delta z minus f of z, which is z square minus 5z. الآن I need to simplify this delta w. We need to simplify it. شوفوا كيف بدنا نعملها simplification. z plus delta z square that becomes تصبح معنا z square plus 2 z delta z plus delta z, all of them the delta z square, minus 5z minus 5 delta z minus z square plus 5z. الآن let us to simplify. عندنا minus 5 with z plus 5z بيروح معنا 0. Again z square مع الماينس z square بيروح in 0. So we will have here it becomes 2 z times delta z plus delta z square minus 5 of delta z. You can take delta z as a common factor, becomes delta z times 2z plus delta z minus 5. And if you go to use the limits, the definition of the limit, f prime of z بتساوي limit لدلتا w على delta z where delta z goes to 0. So that becomes a limit. This is delta w. لا delta z times 2z plus delta z minus 5 divide by delta z where delta z approach to 0. So this delta z will cancel this delta z. So limit becomes just only limit of 2z plus delta z minus 5 where delta z approaches 0, which is equal 2z plus 0 minus 5, which is 2z minus 5. This is according to the definition. Now if you go back to your function here and you derive it with by using the rule without definition, it is exactly the same value 2z minus 5, and by the definition 2z minus 5. واضح المثال هذا؟ Any question for this example? Maybe I can bring another question for you, not this question, maybe another example or another question for you in the exam to use the definition. It is very simple. بلال، كاين عندك سؤال ما شفتش السؤال بتقول لي how. شو هو اللي how؟ but how. Bilal, what do you mean by how in your question? But how, Professor? Your question. I couldn't see. I just saw the question. Where is your question, ya Bilal? In which part, which example? Bilal, in calculus 1, when you learn that if the function is differentiable at a point, that means it is continuous at that point. But if it is continuous, then it is not necessarily differentiable. Have a look at this example. شوف هذا المثال. الفانكشن f of x, this is xy plane. f of x is continuous at the point A, but it is not differentiable at the point A because you have a corner. Do you remember this from calculus 1? So if it is continuous at a point, then it is not necessarily differentiable there. But the reverse is correct. In case it is differentiable, that means you can guarantee it is continuous. That's the point. And to show that the function f of z is equal z conjugate is not differentiable, this is would takes around the 20 minutes to do it. And the class is already done. Let us to do the attendance, to take the attendance, inshallah.